We have this down. All right, so the last thing that I want to talk about is incomplete equivalent fraction. So let me give you an example of that. So if I have a fraction like 5/10, and it's set equal to, let me find an example here, n/2. All right. So we are looking at an equivalent fraction that is not complete. So I need to think about the number relationship between the only numbers that I have so far. Okay? So the only numbers that I actually have that are equal, Eli, if you want to jump in and write something down, that'd be great. The only numbers that I have that are equal to each other are the 10 and the 2. So if I started with the 10 and it became equal to the 2, okay, you can't sit here if you're going to distract me, okay? How did the 10 become a 2? Zach, what could you possibly be talking about right now with an iPad open on that desk that is more important than what I'm saying to you?
I can't really read it from here.
Yeah, what should you do about that?
And I really want to stay in the seat.
Oh, okay.
Oh, just
No, we're going to wait with the video rolling. We'll wait. Okay. All right, so somebody help me out here. I went from a 10 and I became a 2. Now we said the last time we met that when we multiplied, our numbers got what? Got what, Carson?
multiplied.
Uh-huh. When we multiplied, our numbers got what, Jake?
Bigger.
Bigger. Now my numbers are getting smaller, so I probably did what, Audrey?
Divide.
Divided. What did I divide by here?
10 divided by 10. Or 5 divided by 10. Right?
Okay. Well, so basically what we want to know is 10 divided by what equals 2? Right? I mean, that's what we're asking. 10 divided by what? What can go into 10 twice? Carson?
5.
5, yes. So we're going to do divided by 5. Divided by 5. And what I do to the bottom, I do to the top. So n becomes what?
5.
What is 5 divided by 5?
1.
1.
25.
Not 25. 5 goes into itself one time. Let me give you... So ultimately, our answer would be 5/10 is equal to 1/2. Is everybody with me?
No.
Shocking. Okay. Yeah.
I had a feeling it was that because I waited to know about it because I wanted to know if it was right and not get my brain thinking that's what it is.
Mm-hmm.
But I thought that n was 1 too because it would make sense because it's like half 5 is half of 10 and then 1 is half of 2.
Yeah. You'll start seeing the relationships pretty quickly. For right now there are other ways for you to solve this without having to immediately recognize what number has been used for what. But for right now, I really want you to be able to see the relationships between what is happening and start recognizing those. If you take a look at the next one, it's pretty similar. So again, we're starting with 6 and we end up with a 3. So 6, I went down to a 3, so the numbers are smaller. So what did I do? Then
Divided.
I divided. So I have 6 and I divided by something and my quotient or my answer became a 3. So what did I divide 6 by to get a 3, Zach?
2.
A 2. 6 divided by 2 is equal to 3. So what I do to the bottom, I have to do to the top. Alexander, is this your ring?
Oh, yeah. Thank you.
You're welcome. All right, and that is a... What is 2 divided by 2?
4. Well, no, divided by 1.
1. So n is equal to 1. And my answer is 2 6 is equal to 1 over 3.
Yeah, it just worked really fast.
What's that?
It just went really fast. I feel blind.
Maybe that's a little better. We'll focus it in there.
That helps so much.
All right, so let me... Thanks, guys. No, I appreciate it. All right, so let's do 2/3 is equal to n over 12. Okay, so now think about what we talked about. When we divide, our numbers get smaller. When we multiply, our numbers get bigger. So our first clue is that the numbers that we are able to connect together, the 3 and the 12, are getting bigger, right? I went from a 3 and it became a 12. So what am I doing with those numbers? Audrey? Multiplying. So I have taken 3 and I've multiplied it by something to become 12. What did I multiply by, Colton?
4.
A 4. So 3 times 4 was equal to 12. What do I do to the bottom? I do to the top. So 2 times 4 means that n is equal to what? 8. All right, so ultimately we have 2/3 is equal to 8 over 12. So these are equivalent fractions.
I thought.
You good?
Wait, where did we get the 4 from though? Well, I thought it from the 12 and the 3.
From the 12 and the 3. So because I had a 3 and it's equal to the 12, I don't know what the 2 is equal to, right? But I know 3 is equal to 12. So because the 3 got bigger, I had to have multiplied it by something.
And then you just figure out what that is.
So I had to figure out what times 3 gives me 12. If I did it on the bottom, I have to do it on the top. Okay?
Thank you.
Yeah.
Why'd you do multiplication this time?
To show you both.
Oh. If it was division, would it be n? Oh, I get it.
N would, if it was division, it would have started big and gotten smaller.
And 2? Well, this is the only.
No, it wouldn't work on this because the 3 is equal to 12. If it was 12, if I put like the 12 over here on the left and it equaled 3, then it would make more sense. I would have divided by 4. But because the 3, I start with the 3 and I end up with the 12, it has to be multiplication.
I did 4 divided by 2 and I got 2.
Okay. Congratulations.
Is that wrong?
Well, you already had a 2 here. I'm not sure where you're talking about putting a 2.
In the blank.
Oh, crap.
No, because 3 divided by 2 is not 12.
No.
In what blank?
In the end.
Oh, yeah, that would be wrong. Because the n is what goes over the 12, and that's an 8. Because we said 2 times 4.
Then why is division different?
Okay, I'm going to have to show you a whole separate problem. Let's go ahead and stop right there, and then let me give you another example, okay? All right, as a matter of fact, let me do one more down here. And then I'm going to give you guys a couple to work on. Is everybody okay if I move on from here? Yeah. Let's do... Okay, let's do this. So let's do 7/8 is equal to n over 4. Right, Eli? You got this down? Good. Are you there? Don't lie. Now, pay attention here. So what we want to focus on is, again, what is it that we know? 7 and n, 8 and 4, right? So whatever 7 is, whatever n is, they should be equal to each other as far as our fraction is concerned. But what I do know down here is I can compare the 8 to the 4. That much I know. So if I'm starting with 8, Carson, and it ends up equaling a 4, I know that I've divided because my number has gotten smaller. I've taken the 8 and I've separated it into 4s, okay? So what I need to do at that point is figure out what I did with 8. So what I know is that 8 has been divided by some number and now it equals 4. Okay, so right here is where we're at. Carson, are you with me? Yeah. So I need to know how 8 became 4. I know I divided because it got smaller. So 8 divided by what is equal to 4? No. Audrey, do you know? No, but good try. Who was in the back? Krieger. 8 divided by 2. All right, so here, if I said 8 divided by 2 on the bottom, I have to do it to the top because we got to keep it equal. And this was a horrible example. So 7 divided by 2 means that n is equal to 3.5. You're not going to get any decimals. This is what happens when Mrs. Span makes up her own problems. Okay, and that means that our final answer is 7/8 is equal to 3.5 over 4. Okay, again, that's a really weird answer. Just go with it. You will not have 3 point anything or any kind of decimal inside your fractions ever again. It was stupid. That's just why I really, really hate making up my own problems. All right. Any questions about that one? So tell me how we're feeling so far. Give me a thumbs up if you're ready to go on your own. In the middle if you're getting there, but you'd like to see it a few more times, or thumbs down if you have no idea what is happening right now. Go. All right. Zach, I'm looking for your hand. I need it up. There you go.
I'm like in the middle between middle and...
Like you're right on the edge.
I probably could do it by myself.
Yeah, I'd love for you to be sitting here and actually watching what we're doing. Yeah.
I want to go sit in the bike chair because I want to move.
Oh, I don't care. You'll just move and do nothing. All right, so let's do this. Hang on a second. So let me give you a few more problems. I'm going to give you, let me see. This is going to be a you do. Okay, so let me give you one problem here. Sure. All right, I'm going to give you a couple of problems. Let me give you two problems, okay? And I want you to go ahead and see what you can do with these. All right, so I need you to solve for n, and I need you to tell me what the equivalent fractions are. So just start with number 1. See what you get, and then we'll work it out together. This is a 4. Sorry about that. It's a little unclear. All right, so if you're watching this, go ahead and we're going to pause it. Go ahead and pause it, and then hit play when you are ready. Check your answers. All right, so while you were working, if you're watching this, we were talking about the options connecting the 9 and the 3. So we know that if the number goes up, it's multiplying. If it goes down, It's being divided. So, because the 9 becomes equal to a 3, we know that 9 has been divided by something, and then the answer is 3. However, one other thing we discussed is that if that's confusing, we can also think of it as 3 times what is equal to 9. So if that helps you, great. If not, never think of it again. So, in this instance, 9 divided by 3 gives us 3. So if I divided the denominator, the bottom number, by 3, what I do to the bottom, I have to do to the top. And so 6 divided by 3 is 2. So n is equal to 2. And now my answer becomes 6/9 is equal to or equivalent to the fraction 2/3. All right? Are y'all with me? So did you need this written out so you know what to do with it, or what was the problem?
I was doubting myself the entire time, thinking I wasn't right, and I was right about everything.
That is exactly what I was wrong.
Hey, now part of the problem is that we divided this up, and you did part of it early this morning, and now we're doing the other part now, and you've disconnected why we're doing this at all. Okay?
Yeah.
So that's part of the problem, is that we're kind of like, wait, what? What is this even about? So if we went back here, if we jumped over here to number 2, and I just said, okay, make an equivalent fraction. Forget what's unknown, forget any of that. What we're doing is we are making fractions that take up the same space, that have the same value, that are worth the same percentage. All right? And we can come up with a number for 4/16 by multiplying the top and the bottom by the same number, or because these numbers are pretty big, I could divide by anything I want and come up with an equivalent fraction. So, for instance, I could just multiply the top and the bottom by 2, which would give me 8/32. Are y'all with me?
Yes.
So that 8/32 is an equivalent fraction to 4/16. I could also, y'all write that one down, and then let me.
Will you want us to write this?
I would.
Oh.
It's up to you. I mean, I'm writing. I also have some other options here. A number that will go evenly into 4 and 16 might be 4. So I could divide by 4. Right? If I want a smaller equivalent fraction, I could say 4 divided by 4 is 1. 16 divided by 4 is 4. So I have 2 choices that I can use there. I can multiply my numbers, both of my numbers, by the same digit, or I can divide both of the numbers by the same number. Now, ultimately, this is what we end up with. We started with 4/16. 4/16 is equal to 8/32 and is equal to 1/4. That means that 1/4 is equal to 8/32. It means that 1/4 is equal to 4/16. They are all 3 equivalent fractions. If I drew a picture of all of these fractions, they would look exactly the same. Again, picture the cake.
Can I write it?
Picture the cake. Yeah.
Or I'm gonna write it
If
down.
I take a cake, if I have 3 different cakes, and I break one into 4 big slices, I just cut it down the middle, cut it across. If I take a cake and cut it into 32 little bitty pieces, or I take the third cake and I cut it into 16 pieces. By the time I take that top off, if out of the 16 slices, when I take 4, out of the 32 slices, I take 8 pieces, or if I take one chunk of the cake pushed into 4 pieces, focus please, they're going to look the same. It's the same amount of cake gone. They are all equal. Yeah, Carson, question.
Can I sit right there so I can see better?
Yeah, of course.
What's the name?
Josh, did you have your hand up? Yes. All right. Are we okay here?
Yes.
All right. So go ahead and work this problem out and hit pause when you're ready to check your answer. All right, let's bring it back. So just for, hey. All right, so I think most of you are on board, but let's just walk through in case somebody did not ask for help. So again, we're looking at what we know, which is that 12 becomes 6. Because that 12 gets smaller, I know that I'm dividing it by something. So 12 divided by 2 is actually what gives me 6. That means that I divided by 2 on the bottom. So now I'm going to do divide by 2 on the top. 4 divided by 2 gives me 2. So n equals 2. And if I go ahead and just write that whole thing out, I now know that 4 twelfths is equal to 2 over 6. All right, anybody not get this answer? Carson, I'm pretty sure you did get this answer because I checked your work. All right, everybody else okay on this? All right, now the other thing that I want to jump back into is the comparisons that we did this morning. So, you missed, so probably ought to get over there and pick up your mess. Oh, you did, you little baby boy. Gotta check that diaper. Gotta check that diaper. Nope. All right, so, but if it really matters to you, you can number it whatever you want.
But isn't that number 4 because you...
Oh, sure, number it number 4.
Sure,
All right, so now we talked this morning originally about comparing two fractions. So if I give you something like 2/8 and we compare it to 3/4, right? I want to know which is bigger, the 2/8 or the 3/4. Now we talked about a couple of ways to do this. The first way was that we were going to compare each of these to half of what they would be according to this denominator, right? So when I look, and I'm just going to write these over here, when I look at 2/8, because I have 8 in my denominator, that means 4 would be half, right? Are y'all with me?
No.
Yeah.
So if I had 4 out of 8, that would be about half. Now, which is bigger? 2 pieces out of 8 or 4 pieces out of 8? The 4, right? So the 2/8 is not, it's not even half. So what I'll do next is look at the 3/4. Now, the 4, again here tells me how many makes a whole. So what would half of that be, McKinley? Of a fraction with the 4 in the denominator. You guys stop talking, or I'm not gonna stop. Okay. Good night, nurse girl. Give me that. Okay. So again, if there was an 8 in denominator here, we said half of 8 was 4. So that fraction would be 4/8. That would be half of 8 pieces, right? 4 would be half of the 8 pieces. So if I have 4 in my denominator here, McKinley, you with me? If I have 4 pieces, what would half of that be? 4 makes the whole cake. 2. So that would be 2/4. So again, now I'm comparing 3 out of 4 pieces to 2 out of 4 pieces. Which one's bigger? The 3. So here's what I know. 2/8 is less than half.
Yes.
3/4 is bigger than half. So which fraction is bigger? The 3/4.
I'm so smart, Miss Van. Which one would be bigger if it was 3/8?
Versus what?
2 8s.
The 3?
I would love
If they have the same bottom number, then you're just comparing what the the number is on top.
If it was like 5 8s
Yeah.
and like 6 8s, would it still be the 6th one?
Yep. Because if they have the same bottom number, then whatever is on top wins. The bigger number on top wins.
One more.
Let me give you another problem. I want you guys to look at this one on your own. Okay? Let's do another one on your own and see how we do. Okay. What would this? I think this one would be number 4, but for some of you, it might be. It really doesn't matter. What about? 1/5 and where'd it go? 2/10. So I need to know which is bigger, 1/5 or 2/10.
What's happening?
All right, so let's take a look at this. Now, one thing that we have to think about here is that both of these, I can tell you right now, are less than half. Okay? So we need to think about them a couple of different ways. One thing that we do know is that the 5 is definitely half of the 10, right? So I had to multiply 2 to get there. But the question becomes, what does that even look like? If I start out here and I make 5,
Do you have to draw that?
no. So here's 5 pieces, and I color in 1/5. Now I said that is equal to 2/10, right? So that means I had to multiply it by 2. I draw a line through it. Now I have 2 out of 10, and they take up the same amount. Y'all, they take up the same amount. So what I needed to recognize here is that they're equal to each other. Because look at the relationship between the numbers. 5 is half of 10. 1 is half of 2. Y'all, these are equal. Yeah.
I didn't do that's not how I did it.
Okay, how did you do it?
Well, I just kind of did I did 1 minus 5 equals 4, and 2 minus 10 equals 8, and 4 plus 4 equals 8.
Okay, I think that was a coincidence. I don't think that's going to work in the real world.
Okay.
But it's interesting that it worked.
Yeah.
Carson, how did you come to your answer?
Wouldn't 2/10 be bigger because half of 5 is 2.5,
Can I go?
Uh-huh.
right?
It's my turn.
Okay.
So I have to go get water.
No, I haven't even wet yet.
It was me and then you.
No, it was
No,
Carson.
it was Carson.
It was Carson and then you.
Go!
It's 2.5 and 1 would be 1.5. So 2 would be bigger by 0.5.
What?
Okay, I'm showing you mathematically that if I go from 5 to 10, Eli, I'm done with you. That's going to be another check, all right, for talking. I went from 5 to 10 by multiplying by 2.
Yes.
I went from 1 to 2. I multiplied by 2. Those are equivalent fractions.
But half of 5 is 2.5.
Okay, that has nothing to do with anything. 5 times 2 is 10. 1 times 2 is 2. They are equivalent fractions. They are equal to each other. One more. Hang on. What about 1/4 and 1/8? No, and stop yelling out and asking if you can go after Carson. All right, so take a look at that. Let's take a look and try to decide which one is bigger and go from there. All right, so let's take a look at this. Grace, what did you get?
1/4.
That 1/4 is bigger?
Yeah.
Why? She said 1/4 is greater. Because why?
The 4
Mhm.
is less than 8.
Okay. But what does that mean as a fraction, though? She's saying the 4 is less than the 8. Somebody help her. She knows what she means, but she has trouble saying. Audrey, help your friend. How do you know 1/4 is bigger?
Because when you draw the thingamajigger,
Mhm.
1/4, or the picture 1/4 is bigger, but when you draw 1/8, it's only one box and nothing.
Bruh.
Yeah.
Okay. So visually, so you drew a visual and you could see it. Somebody else. Weston, how did you know?
I started drawing the visual, but
Mhm.
then I looked ahead and I'm like, oh, if I do it like that, like I was gonna make diagonal lines.
Yeah.
And I'm like, oh, but that's a full one, and that would only be half of that.
Okay. Because the piece of the 1/8 would be smaller than the piece of the 4th.
Yeah, it would be like half.
Okay. McKinley?
This might be a dumb way to do this,
No, tell us what you got.
but I got the right thing. So the way I thought about it was because of the, like, 1 is closer to 4 than it is 8.
Mm-hmm.
So then I knew the 4 was bigger because it was closer.
Closer. Okay. Yeah. Violet.
I looked at the denominator. That's how I always made it lesser or bigger
Mhm.
because of the denominator. If the denominator is bigger, then the piece is bigger, which makes it have more value.
Okay, so let me say something there. So we're talking about here. First of all, the numerator is the same. It's 1. It's 1 piece of the cake for each cake. Now, what is weird about fractions in this case is that the smaller number actually wins because I have the same cake, 2 of them, the same cake, but this one I have cut into 4 pieces, and this one I've cut into 8 pieces, right? So which piece is going to be bigger?
1/4.
The 1/4. Absolutely. So I did have some friends that were trying to say, okay, these are equivalent because the 4 times 2 is 8. Because you have to, whatever you do to the bottom, you have to do to the top. Okay, yeah. Colton. Of course you can. All right, any other questions about this one? If you had to draw a visual, that's great too. Okay, but yes, either any of those strategies work. We just want to make sure that they match. Also, though, if you had looked at 1/4 versus what would have been a half, right? If out of 4 pieces, half would have been 2 out of 4. If I'm looking at 1/8, half would have been 4 out of 8. So one other thing that I could do here is say, okay, neither of these are as big as half. They're both smaller than the half, but how many slices away are they from being half? And this one, I only needed 1 slice, right, to be half. But how many did I need for this? I needed 3 more slices to be half of the cake. Are y'all with me? So you can also look at, if they're both smaller than the 1/2 mark, how many more numbers on top do you need before it equals half? So you can look at that as well and go from there. All right, so let's do this real quick. Go ahead and take out your math workbook and let's open to page 106. Eli, let me see yours, please. Math workbook. All right, so let's open up to page 105, 106. Go ahead and put your name on it. 105 and 106. All right, so here we are at renaming fractions. And let's go ahead. We're going to put our name at the top. And here I'm going to say due Friday for, so what is today? The 9th, 10th, 11th, 12th. Is that right? Yeah. All right, so this will be due Friday. Don't forget that tomorrow your comparing fractions is going to be due, okay? The first one that we did, and that this will be due on Friday. You were out for that one. Okie dokie, everybody with me? So let's take a quick look at all of these and make sure we understand what to do. All right, so here where it says repartition the figure to make an equivalent fraction with higher terms. Okay, so when it says higher terms, it means that our numbers are going to get bigger. So when they get bigger, what are we doing? We're dividing? No, we're going to multiply. Okay, so what I'm going to do to repartition, that's like a fancy way of saying like cut or add lines, right? So what can I do to this square that's cut from right corner to bottom left corner if I want to make it even? I can't cut it straight down the middle. I can't cut it straight across. Since they have cut from opposite corners, guys, I am going to draw a line from opposite corners. So before, I had 1/2 of that square marked and shaded in. Now how many do I have out of the 4? The 2. All right, so you're going to do that every single time. Now notice it says higher terms. So find a place to draw that line to create the correct amount of spaces that you have in the denominator. Okay? All right, jumping down to 7 through 12. Now this is exactly like what we did when we jump back in this afternoon. All right, they're giving you an unknown variable. Anytime you see that variable in there, it's unknown. So we need to know what n is. For number 7, you've got 9 and it becomes 18. What did we do to the 9? It got bigger, so we did what to it? Carson? We multiplied. Yeah, multiplied by 2. So what I do to the bottom, I do to the top. Thank you. 3 times 2 is? 6. Yeah, 6. No. It was something personal. With something about his family, that's all I know. Forever? I guess. Yeah. All right, any questions about that? So you're going to do the same thing with the rest of these, okay? So we know what to do there. All right, numbers 13 through 15. They say in the directions, draw a picture and write the equivalent fraction. Now notice it's very specific. This one says shade 3/4 of a square, repartition to show 8ths. So I've got 3/4, and they want me to make something with 8ths on the bottom. So you can go ahead and you can do a visual, or if you want to just figure these out for yourself, you can as well. Now, notice on number 14, it says 2/3 repartition to show 12ths. So I'll have 2/3 is equal to what? What number is going to be on the bottom here? I'm going to wait for more hands up. Repartition to show 12ths. What number is going to be on the bottom of those fractions? What do you think, Weston? Right here, repartition to show 12ths. What number is going to go down here on the bottom? What's a 12th?
It's like cutting it if you were.
It's a 12. It's 12. It's out of 12 pieces. A 12th. 12 pieces. It sounds fancier than it really is, right? Are y'all with me? So again, an eighth, we made into a number over 8. The 12th we made into a number over 12. So we're just, guys, you're going to figure out the n here. Now I'm going to let you read number 15 and see what you can come up with. Because they want you to figure out the mistake, so I'm going to let you. Now, sounds like we're almost out of time, but I'm going to go ahead and just power through. It's due Friday.
This video's been going for 40 minutes.
I know. Okay, so let's go ahead. Page. So let's take a look at page 106 real quick and make sure we're all understanding what to do on this assignment. So down here at 16, 17, 18, it says to circle or draw lines to group the figures, write the equivalent fraction in lower terms. So I've got 2 sets of instructions here. First, I need to circle or draw. Then I need to write the equivalent fraction. So on number 16, it tells me 2/6 is equal to, give me that. Eli, thank you. All right. Is equal to something in the third. So my denominator is in the third. So what I need to do is I'm going to draw my lines here to make sure that my picture is pictured into thirds. Are y'all with me?
Yeah.
So here, if I had this is also into thirds, I would probably do like this, maybe, just to make sure that I can see 1, 2, 3. And then over here, I need to, break this one into 4. So what do you guys want to do with this one? Circle them, yes.
Or you can,
you can box them, or circle them. Any of that will work.
Did you need to start?
But there are your 4 columns. All right, so then you're going to write the equivalent fraction in the lower term. So now that we've put this one into thirds, what would I put here for my numerator? How many are shaded? All right, go ahead and let y'all fill that in now that we broke it down into 3 pieces. Any questions about that?
Yes. One question.
Okay. Yep.
On the one with the triangle, it kind of looks like a square now. It kind of looks like a box now.
Okay, remember that if you choose to leave while we're working or doing notes, that's on you. So I'm going to leave this up for like 30 seconds and then we are going to move on. Yeah, Carson?
Did you mean to start a new recording?
Yes, because I'm going to tack it onto the other one. But thanks for pointing out that I have a new recording. So now when I splice it, it will be obvious because I have to answer.
Like a square now.
Oh, good. All right, so next section, 19 through 25. It says divide by a name for 1 to find an equivalent fraction in lower terms. Divide. Okay, well, they're being weird. All right, so basically what they want you to do, again, is what we've been doing here. Like on number 19, let me just push in there real quick. So, again, 6 divided by 6, I'm sorry. Rewind. 8 and 4. So 8 divided by what equals 4? This is the one that they're referring to, okay? 8 divided by what gives me 4? Anybody? Yeah, McKinley? 2. So what I do on the bottom, I do on the top. 6 divided by 2 is 3. And you're done. Any question about those? Carson?
If 2 times...
Nope. That's it. Es todo nomás. You are not making this complicated. No. Just divide. All right. So that takes you through number 25. Let's bounce over here to the next section. Now it just says to write greater than, less than, or equal to compare. So you'll have a couple of options here. You can compare them to 1/2 of what they would be, right? You can draw. You can do any of those things. All right? Do any of those things. But go ahead and you will just put these signs in to show the relationship. Any questions about those?
No.
All right. You know. Okay. And then, last but not least, we did a little bit of this morning, so look back in your notes if you need to. Come on down. This does not want to go so low. All right, so we will take these fractions and we will put them in order from least to greatest. So again, like with the ninths, we can compare these two pretty quickly, right? Which is bigger, 4/9 or 5/9?
4/9. No, 5.
5/9 is bigger, right? So this one's bigger. So what is bigger than 5/9 or 1/3? So, okay, I hear somebody saying 1/3. How do you know that?
Because the denominator is smaller.
Okay, but 5/9 is bigger than half. 1/3 is not bigger than half. Okay, so I'm going to assume that 5/9 comes last. So did y'all hear that? When I'm comparing to halfway through, 4.5 would be half of 9, right? 5 is bigger than that. So 5 is bigger than a half. So it's going to be the biggest. The next thing I need to know is which is bigger, 4/9 or 1/3. So again, I'm comparing just like I did above. If I'm looking at a number, so like if I am looking at the number here in the denominator 9, I'm going to divide 9 by 2 and I get 4.5. Okay, are y'all with me? So 4.5 over 9 would be half. It's weird, it's a fraction, but that's okay. So 4/9 is almost half. Half of 1/3 would be 1.5. Guys, these are, I think that they might be equivalent. No, maybe not. Maybe not. So 4.5, 1.5 over 3. So they are, so really they're both almost halfway through, but what is going to be bigger, a 1/3 or a 9th? A 1/3. Because it's out of 3 pieces. Okay? So make sure you're comparing them and walk through. So you'll just put them again in order from least to greatest. Any questions about that? Be 12 over 9. Oh, you know what? Actually, that would be opposite. That's incorrect. So the answer for this would be 1/3,
You changed yourself.
4/9,
You tried to fail.
and then 5/9.
I knew it.
Why would I try to fail you?
I'm so smart.
Well, I just looked at it again and I'm like, wait a minute, no. Okay, any questions about that?
Yes.
Yeah, Carson.
I thought you said that like the smaller the number is, like the bigger it gets. Like with the other one, 1/4 and 1/13. And 1/8. And 1/8.
No, I can't wait to hear what's coming out of your mouth. I mean, this is exciting. You gobbledygook.
You said that.
But you're on the phone, and now my student's watching what you're doing on the phone. That's distracting. Absolutely, Carson. Good job. All right, so this is going to be due on Friday. Why don't you guys take the time right now to finish? You can work on this if you are done with the comparing fractions, okay? Or you can work on that. That is due on Wednesday. All right, go, bye-bye.